Well, let's see. We left off on number 59 last time, doing unit conversions. Let's do a few more of these, and then we'll move on to the next section. So, newborn baby. It's 53 centimeters long. How many inches long is she? Well, let's find our conversion tables. Let's see, here's one. And here's the other. So we're looking at centimeters to inches. 2.54 centimeters make an inch. So 2.54 centimeters is 1 inch. And we want to convert 53 centimeters and multiply it by the number 1. We'll do a smart 1. We've got to get rid of centimeters. We want inches. 2.54 centimeters is the same as 1 inch. We have our inches here. So now we just take 53, divide it by 2.54. We get 20.87 centimeters. And that's 62. So we've got 64 here. All right, last year, Daniel donated 1,892.72 milliliters of blood. If a person donates 1 pint each time, how many times did Daniel donate blood last year? All right, well, let's see. We got 1,892.72 milliliters. So we're talking about pints per time, right? So we need to convert milliliters to pints. Let's see what we can do up here. Here's our pints. We can go pints to fluid ounces. Here we go, milliliters to fluid ounce, and then fluid ounces to pints. So there's 29.57 milliliters in a fluid ounce. So we get rid of milliliters per ounces. There's 29.57 milliliters in an ounce. Now we can get rid of ounces for pints. 16 ounces make a pint. So 16 ounces make 1 pint. Ounces go away, we're left with pints. So we need to take 1,892.72 divided by 29.57, divide that by 16, we get 4 pints. So if a person donates 1 pint each time, how many times did he donate? Well, we need to do a conversion now from pints to times. They say that 1 pint each time. So pints go away, and we're left with 4 times, which should be obvious, right? 1 pint each time, 4 pints, 4 times. All right, so for these problems, we have a chart here. Let's see if we can read our chart. All right, a child age 4. There's age 4. Weighs 36 pounds. How many milliliters of medicine will they have to take? Well, they need 1 teaspoon. how many milliliters is that? So we need to convert teaspoons to milliliters. Let's see, teaspoons, there's teaspoons. Well, we can convert teaspoons to tablespoons. Then what? Tablespoons to cups. Cups to fluid ounces. And then fluid ounces to milliliters. All right, let's work on this. Let's see. 3 teaspoons make a tablespoon. So, teaspoon, tablespoon. 3 teaspoons make a tablespoon. So now we got tablespoons. All right. I can't see what I'm doing anymore here. 16 tablespoons make a cup. All right. 16 tablespoons make a cup. So now we have cups. All right. 1 cup is 8 fluid ounces. All right. Cups, fluid ounces. I forgot what it was. Let's see. 1 cup is 8 ounces. 1 cup, 8 ounces. So now we have ounces. And 29.57 milliliters per ounce. Get rid of ounces, milliliters. 29.57 milliliters per ounce. So we have our milliliters. We got to do 8 times 29.57. Divide by 3. Divide by 16. And we get 4.93 milliliters. Any questions about this? That was a journey, right? We had to go through 4 different units to get to the unit that we wanted. So 67 here. Blood makes up 7% of a body's weight. If a person weighs 175 pounds, how much would his blood weigh? Well, first let's take 7%, right? So we need to multiply it by 0.07. See how many pounds that is, right? We got 175 times 0.07. It's 12.25 pounds. All right, so we also want to convert this to kilograms. Pounds. We want to get rid of pounds. We want kilograms. Let's see what our chart tells us. Pounds, kilograms. 0.45 kilograms make a pound. 0.45 kilograms make a pound. Pounds are gone. We got kilograms. 12.25. Oops. 12.25 times a 0.45 equals 5.51 kilograms. Questions? Okay. All right. So what about milliliters? So let's see. We got these. We want to convert either pounds or kilograms to milliliters. Let's see what we can do. It's going to be a tough one. We're going to go from milliliters to ounces. So fluid ounce. We can go from fluid ounces to liters. How are we going to go from a weight to a from a weight to a volume. Oh, this is from problem 63. No wonder. Where's problem 63? Well, that's pounds. How many kilograms? Well, it depends on how much blood weighs, doesn't it? We can't assume it's the same weight as water. I don't see any way to do that. Because these are volumes, these are weights. They're asking us to convert a weight to a volume. And in order to do that, we'd need to know the weight of blood per volume. And we don't know that. We need to know weight of blood per volume. If we knew that, then we could convert our weight to milliliters. Well, here's a liters to centimeters cubed. That might do it, actually. Right here is a liters per volume. No, that's a volume to volume. That's not a weight to volume. So no, that still won't work. But we can convert volume to a volume. Liters is a volume. So let's see what we can do. 0.0025 liters. So like this liquid volume, the only conversion from like a liquid volume, all right, to a space volume is right here. 1 liter is 0.001 meters cubed. All right, that's your important one. It's the only thing that'll convert the liquid volume to a space volume. So we can convert this thing to meters cubed. 1 liter is 0.001 meters cubed. Now we can convert the meters cubed to centimeters cubed. Meter, 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 centimeter, centimeter, centimeter. It takes 10 squared centimeters to make a meter, or 100 centimeters per meter. So meters cubed goes away, and now we have centimeters cubed. So we need to see, multiply 0.0025 times 0.001 times 100 times 100 times 100. We get 2.5 centimeters cubed. Any questions about that? Liquid volume to spatial volume. All right, unless y'all want more on unit conversion, move on. Linear graphs. I think y'all can solve these equations here, right? Do I need to go over these basic solve for x equations? I do one. All right, if you want to solve for x, since we're adding here, we don't even need these parentheses. 3x plus an x is 4x. And we got plus 2. All right, this is just 3x plus x plus 2. All right, so if we subtract 4x from both sides, we have x equals 2. This one here is a little different. This minus sign has to be distributed. This is like multiplying by a -1. So you got 14 plus 5x minus 3x, and then a minus minus gives us a plus 2. 5x minus 3x is 2x. Subtract 2 from both sides. Divide both sides by 2. And we have x equals 6. Check this one out. All right, we got a negative 4x. Up here we have to distribute the 5. We got a 5 minus 5x over 6. So we multiply both sides by 6. We got a negative 24x equals 5 minus 5x. Add 5x to both sides. And then divide both sides by a negative 19. You got something like this. Fractions suck, so the first thing I do is multiply both sides by 7. And that gives us 6 plus 7x equals 13. Subtracting 6 from both sides, 7x equals 7, so x is 1. This one has 2 different denominators, right? That sucks. And if you multiply through by 11, you're not gonna get rid of both of the fractions. What I'd multiply both sides by here is a 77, because 77 is 7 times 11, right? I'll write it like that. 7 times 11, because there's an 11 here and a 7 there. And see why I did that was because now right here you got 7 times 11 times 6 over 11. And then you got 7 times 11y. On the other side, we have 11 times 7 times 11 over 7. So notice all the fractions went away. 7 times 6 is a 42. 7 times 11 is a 77. 11 times 11 is what, 121? So 121 minus 42 is 79. So y equals 79 77ths. So page 63. If we're going to find 3 different solutions for the following equation, all right, there's two variables here. All right, if we graphed it, the solutions would form a line, right? The quickest way is to put this thing into slope-intercept form. So we got it like that, and we just want to get y on one side. So if we divide both sides by a negative 4, 12 divided by a negative 4 is a negative 3, and then we have plus 3/4 x. All right, so to find 3 different solutions, the quickest two is let one of the variables be 0, right? If x is 0, then y is negative 3, right? So 0, negative 3 is a solution. What about if we let y be 0? Put a 0 right here, what would we have? Right, we'd add 3 to both sides. Multiply both sides by 4. So we have 12 equals 3x. Divide by 3, x is 4. So another solution would be 4, 0. All right. And let's see, to find another solution, plug in any number you want for x. What if let x equal 1? If we plug a 1 in right here, y is -3 plus 3/4, right? And 3 would be 12/4. So -12 plus 3 would be a -9/4. So another solution would be 1, -9/4. You get as many solutions as you want. Just let x be any number you want, and then you have your x, and figure out what the y is. Or you could look at all of them by graphing it, right? One way to do that. Once you have two solutions, like this one here, 0, -3, and 4, 0, 2 points make a line. So there's an infinite number of points there. But yeah, to find a solution, just plug in any number you want for x and find the corresponding y. So like this one, it's easiest again if you put it in slope-intercept form. All right, so if x is 0, then y is -16. So 0, -16 is a solution. If x is 1, then y is -8 minus 16, which would be a -24. So 1, -24 is a solution. If x is 2, then y is -16 minus 16, or -32. So 2, -32. There's 3 solutions. Boom. All right, let's look at quiz number 27. Let's see. Some more of these tough ones here. Number 31. Done with that section, so let's see here. I'm gonna go to percentages. So we've already worked all of these, so what am I gonna pick from here? Maybe 87. Let's do number 3 here. For number 2. All right, let's take 15. So 340. We'll reconvene and check out these problems. All right, class. Let's check out these quiz problems real quick. Move this down. So number one here. So after exercising, our heart rate can be modeled by this equation. T is the number of minutes that have elapsed after you've stopped exercising. How many minutes does it take your heart rate to drop to 100 beats per minute? Well, let's see. At time 0, that means the instant you stop exercising, we get 151. If you plug a 0 in for T here, e to the 0 is just 1, right? So we want to know when it's dropped to 100 beats per minute, right? So let's see. We want to know, we don't need to know this. We need to know when R is 100. So we take our equation here and we replace R with 100. And we need to solve for T. Okay? So let's see. If we're going to solve for T here, we can divide both sides by 151. So we have 100 over 151 equals e to the negative 0.055 t. Okay, so from there, to get the t out of the exponent, we need to take the natural log of both sides. All right, when we do that, the natural log and the e2 that undo one another, and we have a negative 0.055t. We're just left with that is equal to this guy. So t is divide both sides by this number, 1 over negative 0.055 times the natural log of this stuff. And let's plug this into our calculator and see what we get. 100 divided by 151. Now we take the natural log. Now we divide by 0.055. And we get 7.49 seconds. So you'll follow that in part A. They wanted to find out how long, meaning the time in minutes, for R to be 100. So we use our equation and we just replace R with 100. And now we have to solve for the time. So to do that, we isolate our exponential by dividing both sides by 151. That gives us this. Now to get the t out of the exponent, since it's an e here, we take the natural log of both sides. And this natural log and the e2 that undo one another. So you're just left with this guy, which is equal to natural log of this. So once you're here, to get the t by itself, you just divide both sides by that number and plug it into your calculator. So that's part A. Now B. Find your heart rate 15 minutes after exercising. Well, this tells us the rate after t minutes. So plug in a 15 for t. T to the negative 0.55 times 15. So this is just plugging that in. I wrote this wrong here though. 0.055. There we go. So I got a negative 0.055 times a 15. Now take the e to the button and then multiply that by 151. I got 66.17, and this is minutes. Any questions about that? Part B? All right, let's look at number 2. George leases a machine for his business. He pays an initial fee of $1,000 and then a maintenance cost of $115 a month. So A, write a function C of X that calculates the cost of leasing the machine for X months. So the cost after X months, well, he pays $1,000 initially. All right. So if you plug a 0 in, you get 1,000. But now he has a maintenance cost of $115 a month. So we need to take 115 and multiply it by the number of months. So the number of months times $115 a month plus the $1,000 fee. So that is our equation. How much is he paid at the end of 1 year? 1 year is 12 months away. So we just plug a 12 in. We have 115 times 12 plus 1,000 equals $2,380. Any questions? All right, since there's only 4 of y'all today, we're going to cut out early. I'm just going to throw you your exam here. 27. And I'm going to pick some of these linear equation ones here. So be number 1. And since y'all are the only ones here, if you like, we can work this exam together. Is that cool? Y'all
Yeah.
want to work? All right, let's do this. So these are the ones where there's 2 things to figure out. Move this down. And you need to come up with 2 equations. So here they say Myra is selling 2 types of candy bars for a fundraiser. Sour Sillies and Choco Nuts. On the first day, she sold 2 Sour Sillies and 4 Choco Nuts for $10. So that gives us 1 equation right there. On the second day, she sold 4 Sour Sillies and 2 Choco Nuts for $11. Find the price of each type of candy bar. So that tells us what the variables are right there. Let's say S is price of Sour Sillies. And let's let C be the price of Choco Nuts. So on day 1, 2 Sour Sillies. So if we take 2 times the price of Sour Sillies and 4 Choco Nuts, so 4 times the price of a Choco Nut, she made $10. The second day, she sold 4 Sour Sillies and 2 Choco Nuts, and she made $11. All right, so here's our 2 equations with 2 unknowns. All right, one way to solve this is by substitution. That's probably the easiest way, or we can do process of elimination, okay? I'm going to do substitution for y'all since I think that's the easiest conceptual way to do it, although the elimination would be quicker, right? So let's just rewrite S here by itself. So we got a 2S is a 10 minus 4C. So S would be, divide everything by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. So now that we know what S is in terms of C, right, we plug that in over here. All right, so if we do that, take this S and replace it with the 5 minus 2C. So what this is one equation with only one unknown, just the letter C. And now we just solve for C here. 4 times 5 is 20. We got a minus 8C and a plus 2C equals 11. So negative 8C and 2C is negative 6C. Now 11 minus 20 is negative 9, right? So divide both sides by a negative 6. 9 divided by 6 is 1.5. So that would be $1.50. 9 divided by 6 is 1.5. So Choco Nuts cost $1.50. Now that we know what the Choco Nuts is, since we already have S in terms of C, S is 5 minus 2C. So this is 2 times $1.50 is 3. So this would be $2 is S. Think y'all can handle these types of problems? You got to get your two equations, and then you substitute one into the other one. I do post the notes right after class, so if you need more time, you can check it out right after class. All right, Tim Duncan of the San Antonio Spurs once scored 36 points on 22 shots in an NBA game, shooting only 2 points and free throws, which are 1 point. How many types of each shot did he make? Let's let R be the number of regular 2-point shots. Let's let F be the number of free throws. So let's see, one day he had 22 shots total and scored 36 points. All right, so if he had 22 shots, that means the number of regular shots plus the number of free throws was 22. Right? So that's one equation. Now this 36 points thing, let's see. The regular shots are worth 2 points apiece. And the free throws are only 1 point. So we could put a 1 here, but there's no need to. So 2 times the regular shots plus the number of free throws he made should be 36. So there's our two equations. So if we take this top one and rewrite R in terms of F, now we'll just plug it in down here. So we got 22 minus F plus F is 36. So now we have one equation with one variable. We could solve it. We get 44 minus 2F plus F is 36. Negative 2F plus F is a negative F. 36 minus 44 would be the negative 8. So F is 8. Since we know F is 8 and R is 22 minus F, 22 minus 8 is 14. Yeah, 14.
Yeah.
And we can, of course, check our answers, right? Are the number of shots add up to 22? 14 and 8 add up to 22. And we can also plug them into this equation and check to make sure. Twice R would be 28, and then plus F, 28 plus 8 is 36. So they satisfy these two equations, so we know we're good. All right, class. We do not have classes on Thanksgiving, so I'll see you the following Tuesday.
You have a good one. Happy Thanksgiving.
You too.
Happy Thanksgiving.
All right, bye, y'all.